Assalamu alaikum, dear students. Hopefully, all of you are well, right? Today, I welcome you all to our today's question bank masterclass. And in today's class, we will be discussing lecture 4 of chapter 3, which is periodic properties of elements and chemical bonds. Today, we are going to discuss we are going to solve questions from this topic, which is periodic properties of an element. This topic is one of the conceptual topic from which if you understand the basic concept, if you can grasp the concept of trends in the period, then you will be able to answer all sorts of questions coming from this topic. What kind of questions usually come? Usually comes, which is basically it comes questions come from periodic trends of different properties. Question also comes from exceptions in periodic property. Most important periodic properties are, which are essential to solve: ionization energy, electronegativity, electron affinity, ionic or atomic radius. Usually, all of the questions appear from these 4 properties. So we don't have to bother about remaining properties. These are the 4 important periodic properties that we need to understand clearly and we need to solve perfectly. As we can see, almost every year from 17 to 17, 18 session to 23 to 24 session, almost every year there was question from this topic. So we can't ignore this topic and we should understand and we should try to grasp the technique of solving a question when it comes as MCQ. So let's start the question. What is the change in energy called when 1 mole of electron are added? When 1 mole of electron are added to 1 mole atom in gaseous state. Okay. So when you get 1 mole electron, you will be negative. You get 1 mole electron, you will be an anion. To generate an anion, the amount of energy required, it will be the amount of energy absorbed will be called electron affinity. So the answer will be first electron affinity. On the other hand, if it was meant for an cation, like 1 mole electron is removed, then it will be first ionization energy. Okay, which of the following element has the highest ionization energy? At first, we should learn the shortcut technique to remember the periodic trends. As we know, from periodic table, from top to bottom there will be group, and from left to right there will be period. I am writing a Bangla mnemonic which is Bidhatar Porikha. Bidhatar Porikha. What does it stand for? It stands for Bijaron, which is reduction capacity, ধাতব ধর্ম বা metallic property, Pori stands for পারমাণবিক আকার, which is atomic size, and also Kha for Khar, that means basic nature. So all these property, reducing capacity, metallic nature, atomic size, basic nature, these are the 4 periodic properties we should remember using this mnemonic Bidhatar Porikha. Now what will we do with this mnemonic? Actually, when we go to grave, when we will die in grave, our accountability, what have we done in our life, we will be accountable for that. So when we will go down, the examination will take place and God will take our exam. God will test us. The test will get increased. And so what I'm trying to say that from top to bottom, the test will increase. That means Bidhatar Porikha will increase. From top to bottom, these 4 property will increase. In group, it will get increased. And we usually demonstrate bad with left side and good with right side. So if you come from left to right, that means if you become good from bad, then the test will decrease. So if in a group, from top to bottom, from up to down, test will increase, but from left to right, the test will decrease. So reducing property, metallic nature, atomic size, basic nature, all of them will decrease in period. So rest of the periodic property, which is not mentioned here, will change in the opposite direction or opposite way than these 4. Okay, suppose we are asking about highest ionization energy. Ionization energy is not included here. So in case of ionization energy, all of them are members of same group: lithium, sodium, potassium, rubidium, cesium, all of them are members of same group. In a group, ionization energy will decrease. Since these 4 properties in a group from top to bottom gets increased, it will be opposite in case of ionization energy. It will get decreased from top to bottom. So cesium will be ionized easier than lithium. Okay, so ionization energy will be more for lithium, will be more for sodium, will be more for potassium, will be least for cesium. So highest ionization energy, the answer will be sodium here. Since there is no lithium in the option, we have to mark sodium. And least ionization energy will be for cesium. That's why it is most reactive. Which one is most reactive? Stable element will be cesium. Unstable, if we consider unstable, then it will be francium. Next question, which one below has the least ionization energy? See, we have already solved this question. The answer will be cesium. You may find that this is not a question from same group. Still, magnesium and calcium, these are located above cesium. So we can easily predict, since these are located at the righter side, so it will show higher ionization energy. And also I should say in a periodic table for ionization energy, electron affinity, electronegativity, you all should know that this shows the highest value and this shows the lowest value or least value. Okay, the trend follows like this: from left to right it gets increased, from top to bottom it gets decreased. Okay, this is the trend. So if I can remember this trend, we can easily answer the question. What is the energy called that is needed to convert an atom into positive ion? Positive ion means electronegativity? No. Electron affinity? No. It is ionization energy. The answer is D. Which of the following ions has the smallest size? This is a very good question. Ionic size, you should remember that cations are smaller, anions are larger. And lastly, the more the amount of charge, the more dash it will be. What does it mean? It means barium and beryllium. Beryllium and beryllium ion. Which one is smaller? Certainly beryllium ion is smaller. Again, chlorine or chloride, which one is bigger? Certainly chloride is bigger because anions are larger. And of isoelectronic anions, I mean, if there are 4 isoelectronic anion or 4 isoelectronic cation, then we need to look for charge. If the charge is more, then it will be more small or more large. I mean, for anion it will be large and for cation it will be smaller. Since the question is which one is got the smallest size, and all of them possess, all of them are what? Cations. Now we need to look that if they are isoelectronic or not. First of all, if we write down the atomic electronic number, then we can atomic number, it is 11. For magnesium it is 12. For calcium it is 20. Again, for beryllium it is just 3. 4. It is what? 4. So these are not isoelectronic. Now, as we can see, only sodium and magnesium are isoelectronic. Beryllium, calcium, these are not isoelectronic. But considering the atomic number, we can easily assume that the beryllium ion is the smallest one. Why? Because it lacks the shell it lacks third shell, which is present in case of sodium atom, but not present in case of sodium ion. Yet beryllium 2+ got lesser number of electrons and lesser number of protons, so we can easily assume that it is the smallest one. And now if you try to solve which one is smaller, sodium or magnesium, these two are isoelectronic. In between these two, I should say that magnesium 2+ will be smaller than sodium ion. Why? Because cations are smaller, and the more charge will be the charge of the cation, the more small it gets. Okay, which of the following has the lowest melting point? Okay, now we need to think like Fajan's rule. Look at the chart here: chlorine, fluorine, bromine, iodine. Anion gets larger or largest in case of silver iodide, right? You should remember that when anion gets larger, polarization increase. Polarization increase will result into more covalent nature. So more covalent nature will result into less melting point and boiling point. So which one got the lowest melting point? The answer will be D, since iodide ion is the largest anion here. Which of the following has the most oxidizing capacity? I mean, which is the strongest oxidant? Reducing property. We have seen that the reducing property decreases from left to right. So in oxidizing property would increase from left to right. So at the right uppermost corner, element with highest oxidizing capacity will be there, which is fluorine. Which most powerful reducing agent is what? Most powerful reducing agent will be located at the bottom left corner of the periodic table. So bottom left corner, we have to determine which is the bottom left, which is not bottom left. Actually, we need to locate if all the options are placed in a single period, then we have to determine which one is placed at the leftmost group. So in this case, lithium is placed in the leftmost group. So certainly we can say that lithium will be the most powerful reducing agent. Which ion has the smallest size? Certainly sodium ion has the smallest size. Why? How can I say that easily? Because this is all of them are isoelectronic, and cations are smaller in case of isoelectronic ions. And we can also make a hierarchy according to their size. How? Here smallest one is sodium. So who will be larger than sodium? Among these 3 anions, which one will be the largest? With the highest charge, nitride ion will be the largest one. As we have learned, the more the charge, the more it will be larger. So in that case, our order will be like this. I think you got my point. Next question, which one is the ionic radius of sodium? It is a thing that if you know, you can be able to answer. If you don't know, you will just, the answer will be B, 0.0098. In such questions, I recommend you, if you know, just mark it. If you don't know, leave it. Because assuming something or marking under assumption always result into mistake. And not always, most of the time result into mistakes. And it would cost you additional 0.25 marks. Your hard-earned number would go away. Which of the following pair of the elements do octet expansion? See, octet expansion is possible for members of group 14, 15. These elements show octet expansion, but not group 13. So we need to exclude any element if it is from group 13. So we can see aluminium is there, it will not be answered, aluminium is there, it will not be answered, aluminium is there, it will not be answered. So what will be the answer? Silicon and phosphorus, since it does not contain any group 13 element. Which of the following ions has the smallest size? In this scenario, we have already answered there that the beryllium 2+ will be the smallest ion. Which sequence about the size of ions or atoms is correct? Okay, sodium, magnesium, aluminum. These are the isoelectronic cations. For isoelectronic cations, the highly charged cation should be the smallest one, or the highest charged cation will be the smallest one. So in this case, this is the ideal way to represent their size. Which one's atomic radius is maximum among the elements of second period? Okay, atomic radius should be maximum for what? Certainly, the atomic radius will be more for this one. Why? Because it got less number of, all of them are located in the second period. But since the atomic number gets increased, so in a period, they will be moving from left to right. As we can see, the atomic number increases and the electron number increases as well. So the attraction between proton and electron gets increased. Since the attraction between proton and electron gets increased, the outermost shell gets pulled inward towards the nucleus. As a result, the radius gets shortened, the diameter gets shortened. So element which are located at the left side and element which is located at the right side, the atomic size will decrease in the following way. In this case, the smallest one will be of the largest size. I mean, smallest in sense of atomic number. Okay. Which one is the smallest in size? In this case, as we can see, oxygen, nitrogen, carbon, lithium, all of them are in the same period. So at the rightmost, the element which is located to the right or the extreme right among all these four will be the smallest one. So in this case, we know lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, right? In this way, we determine the second period members. So as we can see, oxygen is located at the right side, then carbon, nitrogen, and lithium. So oxygen should be the smallest one, and largest one will be lithium. Two elements are A and B. Atomic radius of them are Ra and Rb. Suppose this is an element, this is another element. Their radius Ra, Rb. This one is Ra, this one is Rb. Now, covalent bond radius is equal to dB, but actually this distance is called covalent radius, which is dAb. So what can be written? Ra plus Rb will be equal to dAb. Next question, radius of A and B atoms are 37 picometer and 99 picometer. 37 picometer and 99 picometer respectively. What is the bond distance of AB covalent compound? So 37 and 99, if we add it up, 37 plus 99, then we will get 16, 12, and 30. 136 will be the answer. Which information is correct from left to right in the same period of periodic table? From left to right, in the same period of periodic table, ionization energy will certainly increase. So this is the correct answer. Electron affinity will certainly increase. Electronegativity will increase. Size of atom will decrease. Okay, all of them are wrong. What is the energy called that is needed to convert an atom? We already solved that. This is electron. For positive ion, it is ionization potential, not ionic potential. This is ionization potential. Which property in the first four elements of third period increases gradually? Which property in the first four elements of third period increases gradually? What are the first four elements of third period? For third period, sodium, magnesium, aluminium, right? So what will be increased? Atomic radius, no. We have learned Vidhata Parikha, so it will get decreased. Ionization energy will certainly get increased. This is the correct answer. Rest of them is not correct. Which one's ionization energy is maximum? We know inert gases show highest ionization energy. Apart from inert gas, the second inert gas will be nitrogen. So nitrogen will show higher ionization energy. Besides, you should also learn the exceptions of ionization energy in this case. Exceptions to ionization energy. It can be remembered with a Bangla mnemonic, which is Bebir Noya Manager Police Station. Bebir Noya Manager Alom. Noya Manager Alom Police Station. Police Station. Okay, by this, what do we mean? We meant beryllium shows higher ionization energy than boron. It was supposed to be the otherwise. I mean, boron should show higher ionization energy because boron is placed at the right side. But due to stable electronic configuration, beryllium shows higher ionization energy. Similar thing occurs for nitrogen. It shows higher ionization energy than oxygen. Again, manager alum, with this I meant magnesium and aluminium. Magnesium shows higher ionization energy than aluminium. And lastly, with police station, I meant phosphorus shows higher ionization energy than sulfur. At least we should try to remember these 4 pairs at least for MCQ admission test. Okay, if we can remember these 4 along with their values, then it will be outstanding. Okay, which is the correct sequence of ionization energy? Certainly E1 will be less than E2 and E2 will be less than E3. What does it mean? It means if we remove 1 mole of electron, that it is first ionization energy. If we remove again from that 1 mole depleted ion, then it will be second ionization energy. If we remove again, then it will be third ionization energy. Which is correct for ionization potential? Beryllium, boron? No, this is incorrect. Beryllium should be higher than boron. Magnesium, aluminum? No, this is wrong. Nitrogen should be this way. Phosphorus greater than sulfur? Yes, this one is correct. Option D will be correct. Which sequence of ionization energy is correct? We already learned that, so let's practice. Nitrogen should be higher than oxygen, but beryllium should be higher than boron. But this will be in reverse order. The correct version is written here. Yeah, boron shows least ionization energy than beryllium, and oxygen shows least ionization energy than nitrogen. What is the correct sequence of electron affinity of halogens? Which sequence is correct in case of electron affinity? Okay, let's clear it. For electron affinity, you should know that. Suppose for electron affinity, from left to right, electron affinity will increase, and from top to bottom, electron affinity will decrease. So by that mean, we can say that fluorine should show higher electron affinity than chlorine, right? Since fluorine is located above the chlorine, but it does not happen this way. There is exception. What is that exception? Fluorine is a very small atom, so they do not welcome any further electron. This is called shielding effect. The already present electron, I mean 7 electrons are there, 7, in fact, yeah, 7 electrons are there in the outermost shell of fluorine. So it will certainly not allow any, I mean, it will not try to accommodate any further electron in its tiny shell. Rather, it would be easier for chlorine since chlorine got a higher shell, or I mean, better or greater shell. That's why chlorine shows more electron affinity than fluorine. And you will be wondered knowing that, you'll be surprised knowing that not only chlorine, but also all of the elements that are located in the 4th period. You should know that third period, suppose it is the third period, it is the second period. You should know that the third period shows for p block, only for p block. Okay, third period elements shows higher electron affinity than second period elements. Why? Because of the size issue. Okay, so in this case, chlorine shows the highest amount of electron affinity, then fluorine, followed by bromine and iodine. Which one has the lowest electron affinity? Obviously, the one which is located at the leftmost side and the left bottom, to be precise. Here, as we can see, calcium is the atom or element which is located at the leftmost side. So calcium should show the lowest electron affinity. Actually, the atoms with least ionization energy shows the highest electron affinity. No, actually, I uttered that wrong. The atoms with least ionization energy shows the least electron affinity. That's it. Value of the electron affinity, kilojoule per mole of 4 halogens are given below. Which one will be the more likely to form an ion among them? Okay, so fluorine, bromine, chlorine, iodine, which one is more likely to form an ion? Certainly it will be chlorine, because chlorine got the highest electron affinity, and by this we should also remember or memorize the electron affinity of fluorine. By this time, I think every one of you might know this, because it sometimes comes in the broad questions as well, the critic questions, to explain the nature why fluorine is less. Fluorine shows less electron affinity than chlorine. Then we, in that case, we even have to write down their value, actual value as well. For chlorine, it is 349, but for fluorine, it is around minus 328 kilojoule per mole. Which element's electron affinity is the highest? The one located at the rightmost corner. In this case, the answer is chlorine. What is the value of electronegativity of oxygen in Pauling scale? We should also try to remember fluorine, chlorine, bromine, iodine, nitrogen, oxygen, sulfur, carbon, hydrogen. Okay, at least we should try to remember the electronegativity of this atom at least. Pauling scale is the scale from which we get the electronegativity value. Electronegativity is the tendency of attracting or pulling the shared electrons from a bond. And oxygen shows the second highest electronegativity, which is 3.5. Highest electronegativity is demonstrated by fluorine, and the second highest electronegativity is demonstrated by oxygen, which is 3.5. Next, which sequence of electronegativity is correct? As silicon, sulfur, chloride, all of them are in the same period. So we can easily say that the chlorine shows the highest electronegativity. Which one is chemical property? Certainly acidity is a chemical property. Which element has the highest ionization energy? Sodium, potassium, rubidium, cesium, all of them are the same members, are the members of the same group. So the topmost member will show the highest ionization energy. In this case, the answer will be sodium. Which one has the smallest ionic radius? The smallest ionic radius will be demonstrated by the highest charged cation. In this case, answer will be aluminium. Which of the following would be correct? The correct order of size is magnesium. No, this one is not correct because sodium should be here. It will be correct if it is written this way. Sodium will be larger than magnesium, and magnesium will be larger than aluminium. In this way, it will be correct. The acidity of aluminum oxide is not 3, it's 6. Again, this is wrong. Number of sigma bond in this compound, C2H6, is 6. No, actually, total number of sigma bond we can calculate like this. Total atom minus 1. The total atom is 8, so minus 1 will be equal to 7. So the answer will be 7. The number of sigma bond will be 7. And last option says the orthonitrophenol has intramolecular hydrogen bond. Certainly, orthonitrophenol got intramolecular hydrogen bond, and paranitrophenol got intra and intermolecular hydrogen bond. That's why we can say that paranitrophenol shows higher melting point than orthonitrophenol. Which element has the highest ionization energy? Certainly sodium. We have already solved that. What is the correct sequence of electron affinity of halogen? We have already solved that. Electron of one shell decreases the attraction between nucleus and electron of its outer shell. Electron of one shell decreases the attraction between nucleus. Actually, it means electrons presenting in a shell repels other electrons of that shell is called shielding effect. So the answer will be B. Which of the following pairs has the lowest first ionization energy difference? Lowest first ionization energy difference will be in potassium and rubidium. Why is that so? Because these are very close. I mean, lithium, sodium, potassium, rubidium, cesium. So difference between them will be very small. Instead of sodium, potassium, instead of lithium, sodium. Why? Because from top to bottom, ionization energy gets decreased. So here the lesser value, so the difference will be lesser also. Okay. So if there is a comparison, sometimes you might wonder that why it is not rubidium, cesium. You might wonder like that, why it is not rubidium, cesium, if the same logic applies here. But unfortunately, here is the twist. The difference between ionization energy of cesium and rubidium is slightly higher than the difference between potassium and rubidium. So that logic will not apply. We will not be able to apply that logic here. So we just remember that in group 1, the difference between potassium and rubidium's ionization energy is the smallest one. Okay, which is the correct sequence of electronegativity of 4 elements, namely carbon, oxygen, neon, fluorine? Okay, let's first write down their electronegativity. Carbon shows 2.5, nitrogen shows 3, oxygen shows 3.5, and fluorine shows 4. So what? And neon shows nothing, 0. So neon should be placed over here, and we can easily find out the equation. So the inequality would look like this. Where it is placed, I think this one is the correct answer. There is nothing about nitrogen. I think I can leave nitrogen in peace. Okay, now we are correct. Which one of the following has the lowest first ionization energy? Beryllium, boron, carbon, nitrogen. As we all know, beryllium, boron, carbon, nitrogen, all of them are in the same group. So all of them are in the same period. For same period, ionization energy will get increased from left to right. But here's a but. What is that? Beryllium shows higher ionization energy than boron. That makes boron is the atom which shows least ionization energy. So the answer will be boron. Which property decreases gradually in elements of second period from left to right? Certainly it is metallic property. We have learned that from Vidhatar Parikha. Which is the correct order of electronegativity? Electronegativity, as we have already learned, fluorine should be higher than oxygen, should be higher than nitrogen, and that should be higher than bromine as well. Okay. Which one of the following is most electronegative element? Most electronegative among all these: sodium, magnesium, aluminium, sulfur, aluminium, silicon, phosphorus, sulfur. Carbon is located here, right? I'm just trying to find out their position. Boron is located just above aluminium. So we got all the options here. As we can see, for electronegativity, the carbon will show the highest electronegativity since it is located at the upper portion and the right portion. Boron will be less than carbon, but more than aluminium. Again, not more than aluminium, it should be more than silicon. More than silicon, then we should go for this way. Okay, so I can sum up this way. I can sum up this way that carbon shows the highest electronegativity, then boron, then silicon, then aluminium. So most electronegative, carbon. Second, boron. Third, silicon. Fourth, aluminium. Which has the highest ionization potential? So certainly helium. As we know, from top to bottom, ionization energy decreases. So highest will be at the top and highest for the left. Left or right? Right. At the rightmost top, there is helium. So helium should show highest ionization potential. Which of the following is the correct order of radius? So to determine the correct order of radius, we need to look at the charge. 2, so less, plus, less. Okay, this one is the correct answer. All of them are isoelectronic. All of them carries 10 electrons. Which element's electron affinity is highest? Certainly chlorine. We have solved 3 times. Which one has the least first ionization energy? In this case, in the group 1, the lowermost element will show the least ionization energy. Here, rubidium should be the answer. Which one is the correct order of electronegativity? Certainly chlorine, oxygen, chlorine. Why? Chlorine shows 3, but oxygen shows 3.5. Which periodic property is an exception in case of nitrogen and oxygen? Certainly ionization energy. Here, oxygen should show higher ionization energy because of its position, but due to stability of the configuration, nitrogen shows higher ionization energy. Which one has more atomic radius? The one located at the left in a period shows the greater radius. Here we can see cation formation. That means electron moves away. One more electron moves away in a gaseous state. Determines it represents ionization energy. So the answer will be B. Which one is the correct in case of size? Certainly sodium will be larger than the sodium ion. Which one of the following requires minimum energy to be ionized? I mean, which one shows the least ionization energy? The one at the bottom. Potassium, calcium, magnesium, sodium. Which one should be the answer? Since potassium is at the left side and lower than the sodium, so that will be the correct answer. Next question. To break দিচ্ছে 54 আসছে তো তাও তাড়াতাড়ি হচ্ছে এটা Okay, this question shows that which ion is larger in size. As we can see, there are ions of different charge. There are sodium ion, which is positively charged, and there are negative ions as well. We know larger should be an ion. The larger should be highest charged anion. Okay, so here the answer will be nitrite. Okay, let's move on to the next question. Which one of the following has the least electronegativity? Certainly helium, since it is located at the rightmost corner of the periodic table. Electron affinity value of chlorine is minus 361. It is not that correct. It is minus 348. Bromine is minus 340. Iodine is minus 308. Which element has the greater tendency to form negative ion? Certainly chlorine. Certainly. Which is the correct order according to decreasing alkalinity? Actually, according to decreasing alkalinity, the correct order should be fluoride, chloride, bromide, and iodide. Why? Let me show you. Actually, we know that hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydrogen iodide, all of them are hydroxides. And we all know that hydrogen iodide is the strongest, while hydrogen fluoride is the weakest. Now, if we look at their conjugate base, then we will obtain these anions like chloride, chloride, bromide, and iodide. Now, from Bronsted-Lowry's concept, we know that the stronger acids give weaker conjugate base. Okay, stronger acids give weaker conjugate base. So in that scenario, iodide should be the weakest. Iodide should be the weakest base. And which one will be the strongest base? Strongest base should be chloride. Now, if we rearrange the order, it will be like this: iodide, bromide, chloride, and fluoride. And this is placed over here in option A. So option A is the correct answer. Which property of the first four elements of the third period in the periodic table decreases continuously from left to right? This is certainly metallic property. We have solved it earlier. Which element has the highest second ionization potential? Sodium. The first ionization potential of sodium is low, but the second ionization potential is very high because sodium got only one electron in its outermost shell. So taking another electron would compel a removal of electron from the immediate shell to the outermost shell. So it will be difficult certainly. So here sodium would show the highest second ionization potential. And as we all know, ionization potential would certainly increase from top to bottom and decrease from left to right. Right? Sorry, ionization energy will be increased from left to right and will decrease from top to bottom. But why not? So neon, nitrogen, oxygen will be the answer. Let's see. Nitrogen, oxygen, fluorine, neon, all of them are in the same period. And the highest ionization energy is showed by neon. Then there will be fluorine. Then instead of oxygen, it will be nitrogen. Instead of oxygen, it will be nitrogen. Then it will be oxygen. But this is about second period. Sodium comes in the third period. And as we all know, from top to bottom, ionization energy decreases. But you have to think this way, that the more the number of electrons in the valence shell, the more it gets easier to remove additional electrons than one. I mean, you got 2 electrons, so the second ionization energy will be less in case of you. I mean, calcium got 2 electrons, so calcium, removing that 2 electron is easier in case of calcium. So second ionization energy of calcium will be low, right? Since sodium got only 1 electron in its outermost shell, here rest of the atoms will not come close in terms of highest second ionization potential. Which of the following ions has the smallest size? Certainly, anions with smaller charge. Smaller charge should be smallest in size also. Here we can see -1, but the smaller one is certainly fluoride. Why? Because fluorine lacks the additional shell that fluorine possesses. Which one has higher first ionization energy? Higher first ionization energy is certainly nitrogen. Nitrogen shows higher ionization energy than oxygen. Which one of the following has the smallest ionic size? Smallest ionic size will be demonstrated by the higher charged cation, which is magnesium. Which is the most electronegative element? Certainly fluorine. Which ion has the smallest size? To become the smallest size, you need to be positively charged or among the isoelectronic ions. The values of first to seventh ionization energy is mentioned here. What is the electron configuration in the valence shell of the element? They have said an element between lithium and neon. We don't have to look for all this info. We just focus on this. 1310 kilojoule per mole. We have to remember this ionization energy. This is applicable for what? This is applicable for oxygen. Oxygen, we know this is the configuration for oxygen, and its ionization energy is 1310 kilojoule per mole. In which pair of the following is the second atom larger than the first atom in terms of size? Okay, sodium, magnesium in the same period, but magnesium is smaller than sodium. Bromine, chlorine, not in the same period, but in a group. But chlorine stays upper than bromine, so chlorine should be smaller than bromine. Strontium, calcium in a group, but calcium stays in the upper position than strontium, so calcium should be larger, not smaller. Lastly, oxygen and sulfur. Yes, this one is correct because oxygen is the precedent one, so oxygen will be smaller than the sulfur. Select the correct sequence for the decreasing order of ionic radius. This is not any more difficult, and it is not difficult any longer because we have practiced it a lot. As we can see, cations should be the smallest in size, and the charge will correspond to the size. So 3 plus will be the smallest one, and 2 minus will be the largest one. So the answer will be B. The correct order of the reducing power of lithium, sodium, potassium. Actually, this question came from reactivity series, because if we try to solve it on the basis of periodic table, then we have to answer that lithium shows lower reducing capacity than sodium, and sodium shows lower reducing capacity than potassium. But in case of in case of reactivity series, the order becomes this way. The order becomes like this: Lokaloe ke ba kana. That in that way we remember Lokaloe ke na. In this way we remember Lokaloe ke ba kana. Kana. Actually, in this way we remember lithium, potassium, barium, calcium, sodium. In this way we remember the reducing power. So in that case, as we have lithium, potassium, sodium in the option, the order should be this way. Okay. Which of the following does not express the periodic property of the element? Certainly, the ratio of the neutron and proton plays no role in periodic property. Which property gradually decreases from the top to bottom in the halogen group? Atomic radius will increase, boiling point will increase, because iodine gets solid, iodine becomes solid, and fluorine is a gas, so solid to, gas to solid, so melting point or boiling point will increase. Ionization potential will decrease from top to bottom. Ionic radius will also increase. Which of the following property does not satisfy the corresponding order of the halogen? Electronegativity satisfies electron affinity, perfect. Oxidation power, so far all right. Bond energy should be higher in case of iodine, because iodine is solid, but fluorine is a gas. So bond energy should be higher in case of iodine, not in case of fluorine. The order should be in reverse. Bromine is a liquid, fluorine is a gas. The order in which the rate of electronegativity increase among the following element. Okay. Now these are all from the same group. Is it? Let's find out. CNOFNE. Okay. And after that we get from boron, we should write from boron, carbon, nitrogen, then we get aluminium. And we should try to recall at least 1 to 30 atomic numbers serially. In this way, we can easily answer this type of question. Now, aluminium, silicon, phosphorus, sulfur, fluoride. I think I got all the options. What are the options here? Here we got carbon, we got nitrogen, we got silicon, we got phosphorus. Now we need to determine the electronegativity. Okay. First of all, carbon shows 2.5, nitrogen shows 3, phosphorus shows 2.1, right? Phosphorus shows 2.1, and certainly silicon would show less than 2.1. So in that case, the order will be like this: nitrogen, then carbon, then phosphorus, then silicon. So silicon will show the least electronegativity. The order of increase will be this way: silicon, phosphorus, carbon, nitrogen. Yeah, this is the correct answer. Now, as we can see, which of the following indicates the correct order of ionic radius? The more the charge, the smaller it gets. So this is the correct answer. We know higher charged cation is the smallest and the higher charged anion is the largest. Which element has the highest ionization energy? Certainly fluoride, because it is located at the top right. The value of first ionization energy of magnesium is more than that of sodium. Why? Because sodium got only 1 electron. No, so magnesium is placed in the right side of the sodium. That's why it shows higher ionization energy. So that the effective, exactly, that is the actual explanation. That is, the effective nuclear charge of magnesium is more than that of sodium. The effective nuclear charge is calculated by subtracting the proton number from the nearest inert gas. I mean, the nearest inert gas will be 10. Not 10. The immediate after inert gas will be 18, right? So from 18, if I subtract 12, the atomic number of magnesium is 12. We get 6. And actually, no. We have to subtract the atomic number. We have to subtract the atomic number of the immediate inert gas from the atomic number. So we have to subtract 10 from 12. So we get +2. And in case of sodium, we get +1. This is the +2 and +1. These are the effective nuclear charge. The correct order of decreasing the first ionization potential. Beryllium should show higher ionization energy than boron. So it is correct. This one is correct. With the increase in the, how did I solve that? Just you have to remember the serial: lithium, beryllium, C, carbon, N. We got these 4. In this scenario, lithium shows least ionization energy, beryllium, then boron. Lithium from left to right, ionization energy should be higher, but instead of boron getting higher, beryllium gets higher. After that, nitrogen shows higher ionization energy than carbon. So this should be the answer. Okay. With the increase in atomic number, which of the following property of alkaline earth metal increases? Alkaline earth metal means group 2 elements. So increase in atomic number. So in a group from top to bottom, electronegativity will decrease, ionization potential will decrease, solubility of the hydroxide certainly increase. Solubility of hydroxide compound will increase. Solubility of sulfate compound will decrease. Rest of the property will decrease. Okay. Next question. Which of the following has the highest electron affinity? As we can see, oxygen shows the highest electron affinity. Why? Why oxygen shows the highest electron affinity? Because of the position. Here, if we demonstrate their positions in the correct order: nitrogen, oxygen, fluorine, neon, and sodium is located here. So from left to right, electron affinity will increase, and from top to bottom, electron affinity will decrease. So in this scenario, fluoride ion and oxide ion. Fluoride ion means already they have an electron, so they would no longer attract any more electrons. So in this case, oxygen would show the highest electron affinity. Okay, not oxide, because it is already having an electron. It is already having an electron, and sodium plus would not attract an electron because it already left released an electron to become the cation. Which change requires the highest amount of energy? Magnesium 2 plus to magnesium 3 plus. Or actually, the highest amount of energy will be required for the third ionization potential. This is called third ionization energy. So D will be the answer. Okay. This one is nothing. This one is first ionization energy. This one is second ionization energy. Okay. And what is that? This is also an ionization energy, but it is like zeroth ionization energy. This is like from negative to positive. This is not considerable for the periodic property. At a certain period, the element with the greatest atomic radius is located in the group what? Group 1. No. Yeah, group 1, but at the 7th period. So answer will be A, which does not change along the group of the periodic table. Electronegativity changes, electron affinity changes, atomic size changes, but the valence electron always remain the same. In fact, it determines the identity. By determining the valence electron, we can determine the group. Which of the following has the highest electronegativity? Certainly sulfur. Why? Let's look at the position. Carbon, nitrogen, oxygen, fluorine. After oxygen comes sulfur. After carbon comes silicon. After nitrogen comes phosphorus. So higher electronegativity will be at the right side. So sulfur should show the highest electronegativity, then phosphorus, then silicon, and after that we will get STEM. Okay. With increase in atomic number, boiling point of inert gas, with increase in atomic number will certainly increase, because in the non-metal section, in the non-metal group, MP, BP increase downwards. So you easily can understand for metal group, the opposite scenario will be observed. But that means in case of group 1 and 2, we will see that melting point and boiling point will decrease downwards. In the upward section, we will get solid metals. In the downward section, we will find liquid metals. Anyway, the answer will be increased. Which of the following element with the atomic number of 9, 10, 11, 17, 18 has the highest electropositivity? The highest electropositive element will be located at the left side and the lower portion. So lower left corner should be the element of highest electropositivity. And now among atomic number 9, 10, 11, 17, and 18, we are sure that 11 stays at the left side because 11 is sodium. What are the remaining one? We also know their name. 9 is fluorine, 10 is neon, this one is sodium, this one is chlorine, this one is argon. Right? So position of sodium is at the left. So it will be the element of highest electropositivity. Which one is correct order of activity in halogen in upward sequence? Correct order of activity, if I say, then it should be fluorine, chlorine, bromine, iodine. But actually, fluorine shows high electron affinity, so the reactivity of fluorine will be more than fluorine. Which of the following is the smallest ion? Smallest ion should be scandium. Why? Because it got higher charge. Atomic number Z, but actually you should do not jump into conclusion like saying the higher charge, you will mark them as the smallest. No, that doesn't happen. It doesn't happen this way. First, you have to be confirmed that these are all isoelectronic ions. Only in that case, you will be able to answer that way. Atomic number Z of 3 elements A, B, C are 9, 10, and 11 respectively. How does their ionization energy Iz changes? Since atomic number 11 is located at the left side, if I position it in this way, 11 is here, 10 is here, 9 is here. So 9 and 10 will show highest ionization energy, and on the other hand, 11 will show lowest ionization energy. So in this case, I would say 11 will be less than 9 and 9 will be less than 10. So the answer will be C. In which of the following changes is energy released? Energy is released in case of electron affinity because the sign is negative. Energy is released in accepting an electron. So the answer should be this one. Below are the electronic configurations of 4 atoms. Which atom has the lowest first ionization energy? Lowest first ionization energy will be for an element that is placed in the left lower half, right? In that case, this one is the answer, since it is in the 3rd period and it is located in the group 1. What is the number of positive or negative charges created in the atom due to the loss or gain of electron to that element? Certainly, this is called oxidation number. Which order is correct for ionic radius? For ionic radius, I think higher charge of cation is the smallest. So find it. Higher charge of cation here is sodium plus. So sodium plus should be the smallest. Here option C or D. But we found the correct answer because as we can see, nitride ion is the one with higher charge. It will be the largest one. So D will be the correct answer. Which electron configuration of element has the smallest atomic radius? Smallest atomic radius will be found in case of the left or right. In case of the rightest element. Here we can see if I determine their group number, this one is from group 1, period 3. This is group 16, period 2. This one is group 14, period 2. This one is group 2, period 3. So as we can see from the picture that these are from the same period and this one is located at the right side. So it will show the higher size. Okay. Let's move to the next question. Which of the following is the smallest ion? The smallest ion should be the one with higher charge. So the answer would be magnesium. Which of the following properties is inconsistent with the periodic properties? Certainly density. Density is not near, it is certainly inconsistent with the periodic property. We haven't discussed density as a periodic property. If we add 1 electron in neutral atom in gaseous condition, the energy change that occurs is called adding electron would result into release of energy. That's how we say electron affinity. Which of the following electronic configuration has the largest atomic radius? Certainly at the left one of the same period. All of them are located in the second period. So the left one, which is option A, this one is the correct answer. How does electron affinity change from top to bottom of the same group? Certainly electron affinity decreases from top to bottom. Which of the following has zero electron affinity? Only inert gas shows zero electron affinity, which is argon. What is the electron affinity of sodium? I think we have to remember or memorize this information. It is from the book, which is minus 52.9 kilojoule per mole, but it is not that very important. What is the energy released as a result of adding electron? Adding electron means electron affinity, okay? Which of the following, I think you will not face any more difficulty in determining what is electron affinity, what is ionization energy, what is electronegativity. It is easier. Which of the following elements has the lowest electronegativity? It should be helium. Why? It is located at the rightmost side. Which, and it is zero in fact. Which one is not soluble in water? Insoluble in water should be the silicon dioxide, which is a giant polymer. Which compound has zero electronegativity difference? Okay, then we have to look at the atoms of the molecule. Here we can see all of them are bromine, so the difference will be zero. Which is the formula of ferric perchlorate? Ferric perchlorate. The actual formula of ferric perchlorate is this one. ClO4 is the perchlorate ion, and ferric, for ferric, it should be +3. The most ductile, I mean, it can be converted into any shape. It is gold. Which of the following is the correct order of radius? The correct order of radius will be option A. Why? Because the smallest one got the higher charge in case of cation. What is the atomic radius of sulfur? Atomic radius of sulfur is 140 km. Lastly, 108. Which of the following has the highest second ionization energy? The highest second ionization energy is visible in case of potassium. Why? Because potassium got only one electron. Which one has the least first ionization energy? The least first ionization energy will be observed in case of rubidium, because all of them are the members of same group, and we know ionization energy decreases from top to bottom. Which is the least reactive metal? Least reactive metal would be silver, because it is located comparatively lighter side from the left, lighter side among the three. Aluminium is a metal from P block, and also aluminium is above, so it would be more reactive than silver. Which indicates the highest, actually you should know that silver, gold, platinum, these are the metals with least reactivity, and these answers can be obtained not from periodic table, rather it can be collected or it can be learned from the reactivity series of metals, which is described in the electrochemistry chapter, which is chapter 4 of second paper. You should go through that also. Which indicates the highest electronegativity? Highest electronegativity will be demonstrated by the fluorine, right? So this is the electronic configuration of fluorine. Which is the most electropositive? Certainly, which is located at the left side and the lower portion, that is potassium. Which of the following has the most oxidizing capacity? It is fluoride. Which of the following forms acidic aqueous solution? Okay, let's see. This one forms basic or alkaline solution. This one forms alkaline solution. This one forms alkaline solution as well. The last one is a non-metallic oxide, which will form acidic solution. Which of the following compounds has the highest boiling point? The highest boiling point will be demonstrated by the methanol. Okay, why? Because it can form hydrogen bond as well. Okay, which one will require the highest energy to remove one electron? The highest energy to remove one electron, that means highest ionization energy, will be demonstrated by fluorine, because fluorine already got 17 electrons. They do not want to remove any electron, rather they want to accept an electron. So highest ionization energy will be for fluorine. That's all from our side. We solved plenty of questions, but easy questions. So you don't have to worry about anything. You just practice, and you should learn the values of the exceptions provided in your book. And also I provided the mnemonic. You should recall it and revise it. That's all from our side. Best of luck.